So today we are going to be comparing the Texas Giant versus the Mini Mine Train. The Mini Mine Train will be known as MMT, and the Texas Giant will be known as TG throughout this lesson. This is the chart we will be using. The Texas Giant has a mass acceleration of 37.4 meters per second squared. The Mini Mine Train has 26.5 meters per second squared. They both have the same mass of 800 kilograms. The Texas Giant has a distance of 45 meters, while the Mini Mine Train has a distance of 6.1 meters. The Texas Giant has a max velocity of 29 meters per second. The Mini Mine Train has a max velocity of 9 meters per second. The stopping distance on the Texas Giant is 180 meters, while the stopping distance on the Mini Mine Train is 35 meters. The height of both are very different. The Texas Giant has 46.634 meters, while the Mini Mine Train is 6.096 meters. So the work for the Texas Giant is greater than the Mini Mine Train because you can see the numbers of their work, which we will calculate in a second. The Texas Giant does more work than the Mini Mine Train due to its greater force. So we're going to calculate the work for the Texas Giant. So work it equals force times distance. So we will be multiplying. We have to find the force first. Ugh. So we will be multiplying its mass times acceleration, which you will see that in a second. Mass times acceleration, that is the equation for force, which its mass is 800 kilograms. Times 37.4 meters per second squared. Which then would give us 29,920 newtons as our force for the Texas Giant. Now that we have that, we're going to go on to calculating the work. So work is force times distance. So now we have the force, we can do this. So 29,920 newtons multiplied by 45 meters would give us 1,346,400 joules. That's a lot. But yeah, that's the work for the Texas Giant. Now, what I'm circling now is the joules, which is what work is measured in. Newtons is also what force is measured in. Yep, there we go. Alright, next is the mini mine train. We will be calculating its work as well. So, work equals force times distance. It's the same thing. And so, we need to find the force first. So we will be doing 800, well, mass times acceleration, which we know, which then equals 800 kg, or kilograms, multiplied with 26.5 meters per second square. Which would give us 21,200 newtons. And that would be our force for the mini mine train. Yay! Cool. Alright, now to find the work. So work equals force times distance. We've covered that. And so now that we have the force, we can find this. So it would be 21,200 newtons multiplied with the distance of 6.1 meters. That will give us 129,320 joules. And that is our work for the mini mine train. So now we're going to kinetic energy, the energy an object has due to its motion. The formula for kinetic energy is Ke, or kinetic energy, equals mass times velocity squared divided by 2. Now we're going to find the kinetic energy for the mini mine train, which would be 800 kilograms multiplied with 9 meters per second squared after you put the parentheses, which would then give us, because we're going to already just go ahead and square it, so where the 9 meters per second was, you would put 81 meters per second instead, since we just squared that. And then we draw the divide, and then we get 64,800 divided by 2. And then for our final of our kinetic energy, we would get 32,400 joules, which is also what kinetic energy is measured in. Yay! Okay, now we're going on to the kinetic energy of the Texas Giant. So as we said, that's the formula for kinetic energy is mass times velocity squared divided by 2. Which then we would do 800 kilograms multiplied by 29 meters per second, parentheses squared, divided by 2, equals 800 kilograms, then multiplied with 841 meters per second due to us squaring 29 divided by 2, which would then give us a result of 672,800 divided by 2, And our end result for our kinetic energy for the Texas Giant is 336,400 joules. Yay, cool. And that is our kinetic energy for the Texas Giant. So now we're moving on to potential energy. Potential energy is the energy that is stored in an object due to its positive relative to some position. Potential energy equals mass times gravity times height. So we're going to find the potential energy for the mini mine train. The gravity is 9.8 meters per second squared. So we will take 800 kilograms times 9.8 meters per second squared multiplied with 6.096 meters as our height. Which would then give us our ending result of 47,792.64 joules. And that is our potential energy for the mini mine train. Now we are going to be finding our potential energy for the Texas Giant. Like said before, the gravity is going to be 9.8 meters per second squared. Which would then, we would multiply 800 kilograms times 9.8 meters per second squared times 46.634 meters as our height. Alright, and then that will give us our ending result of 365,610.56 joules. So now we are going to be, oh, whoops. Let me just fast forward. We're moving on to work energy theorem, which is work equals force times distance. We're going to be using that equation to find the force of the brakes on the mini mine train to stop it at full speed. So finding that, we're just going to use the work that we have now, which is 129,320 joules. We're going to set it equal to the force times 35 meters. And then we're going to take the 35 meters and divide it by our work. So it'd be 129,320 joules divided by 35 meters. This will give us our end result for the force of the brakes required to stop the cart would be 3,695 newtons of force. and that's how much force it takes to stop the cart at full speed. And now we're going to do the work energy theorem for the Texas Giant, which we need to find the force again. So we use our work that we already have, which is 1,346,400 joules. And then we're going to set it equal to an unknown force multiplied by 180 meters. So then we're going to take the 180 meters like we did with the other one, divide it by the work. So 1,346,400 joules divided by 180 meters. So that way we can get that F alone, and that will give us a result of 7,480 newtons of force used to stop the Texas Giant carts from moving at full speed. So now we're going to power. It's a little messed up because, okay, so this first one is actually meant to be the mini mine train, and then the next one is supposed to be the Texas Giant. I got my names mixed up, so, but yeah. Just imagine it being different names and then you're good. So for the mini mine train, this one's the mini mine train, okay? We are going to take 129,320 joules, since power is equal to mass times time. We're going to take the work times time. That's also messed up. All right, I was thinking that was a little funny. Okay, sorry. Really should have redo this, but okay. But yeah, that's the time is 4.1 seconds. And then P equals 530,212 watts. Watts is what is it's what's power is measured in. It's its units for power. So yeah, power its units. Okay, so this one is actually for the Texas Giant, and I have it fixed in here where it's, and then we got the whole scratch out moment. Fun. Okay. um so power is work times time, not to get that mistaken with or mistook with meters, or not meters, but mass, sorry. um but yeah, the other one was the mini mine train, this one's Texas Giant. So we're going to take our work, which is 1,346,400 joules, and multiply that with 3.625 seconds. And then that will give us 4,880, 4,880,700 watts of power for the Texas Giant. Sorry. That's a lot of power. Yeah. So I hope you enjoyed the video. That is it. Thank you.